Okay, so in this video we're going to tackle optimization. So one thing that I want to quickly go over, the max and the min of any function. Say you have a function or whatever, it's modeled by f of x. We know that f prime of x at any given point, say here, is like the equation to the tangent line. So, with that being said, when you have something that is here at the exact max, the tangent line will actually be equal to 0. Same for a min. It will be 0. Remember that. That is because the rate of change at that point, when you do the line, the tangent line, that will be just a straight line. So, with that being said, let's get into a word problem. Let's say you have 800 meters of fencing, and you have a wall, or say like a road or something. Let's say this is already done. You want to make a rectangle of some sort in which the two sides are x and this. So, this amount. So, basically, you want to maximize this area here. But those dimensions need to be, the same. It has to be a rectangle. So, one thing we can say is that the length of this side is going to be 800 meters. Well, I don't need to write that. Minus 2x, right? So, the area for this is going to be the area of this function is going to be x, which is one side, times 800 minus 2x, which is also 800x minus 2x squared. So remember what I said in the beginning. The derivative of this will give us will give us the maximum of this function. So if we do the derivative, it'll be 800 minus 4x. And if we set this equal to 0, and solve, we should get 4x equals 800, x equals 200. So, what does that tell us? At 200, we're going to get 200 times 800 minus 400. That's just this one, minus 2x. So that should give me 80k meters squared. And there you have it. So x will be 200 dimensions. So we can actually try a different one now. Let's do, this might be harder to draw. Let's say I have let's say I have let's say I have this sheet that is 60 centimeters on one side and 30 centimeters on another side, and I want to make this sheet into a box. I want to fold it upwards. But I want to fold the edges by a certain amount of the same amount on every side. X on each side. But I want it in a way that will give me the largest volume possible when I fold this into a box. So I know that my box's height when I fold it will be X. My length will be 60. Let me write this somewhere else. Will be X. Length will be 60 minus what I'm going to lose here and here, 2x, and my width will be 30 minus 2x. So you know that the volume is going to be this formula, like the dimensions. So V of x, V of x is equal to x times 60 minus 2x, 30 minus 2x. And if we expand this, we can get 4x cubed minus 180x squared plus 1800x. And I guess you already know what we're going to do with this. We're going to get the max and the min, well in this case the max, so IV prime of x is going to be 12x squared minus 360x plus 1800. I can actually factor out a 12. So, if we set this equal to 0, the 12 will divide by both sides, and I'm just left with this x squared minus 30x plus 150. So I'm going to put this, I need to find these zeros for this. So if you remember in our old formula, we're going to use our quadratic formula, negative b plus or minus x will be 6.3. So I'm gonna go with this one because that one clearly is not feasible in our situation. Because if you plug it into here, you're going to be in the negative length, so cannot be that. So it has to be 6.3. So if you actually plug in back into our v of x formula, so let's put 6.3 back into you should get 5196. Should be centimeter cubed. So yeah,